In this video, we are going to discuss about how to train your YoloV5 model on your custom data set. So this is your boy Akhil Kasare back with another tutorial on object detection. So let's get started. So in this tutorial, what we are going to see is how to train your model completely, which have more than one class in your dataset, how to make changes in a YoloV5 file, and how to train it. So for the sake of this tutorial, I am going to use this detection football versus cricket ball dataset, which is readily available on Kaggle. And this dataset, if you check, is basically it's already annotated. So if you see here, we have train and valid images, and we have labels as well, labels for validation and for testing as well. So you can see here we have in total 1738 files, which are nothing but 868 are image files and 869 are nothing but our annotation file, which is in the format of .txt. So another interesting thing is, like, if you want to annotate your dataset, so you can use this tool like makesense.ai. So in this makesense.ai, you can annotate your images, like it supports YOLO, VOC XML, VGG, JSON, or CSV, and anything. So you just have to click on just get started, drop your image, select, for example, I am selecting this pytorch.jpg. I selected on object detection and I started giving some label like object. Okay, so I'll click here, I'll click on start project, and I'll start annotating from here. So after that, you can select your object detection and you can save and download your annotation files. So this is a very handy tool, you can say, because you have label img as well. So for installing label img, you have to do a lot of things. You have to create a separate environment, and after that you have to install your label me or label img tool inside it. But if you use makesense.ai, it's very user-friendly kind of thing, and it's available like on the web. In website it's available, and you can easily annotate your images, and you can download the annotation files as well as the image files. So coming back to our dataset, so I'll close this. What I did was I downloaded this dataset. So you can see here, like inside my terminal, I have already downloaded my dataset, and I have already converted my dataset into zip, and I have uploaded my dataset into my Google Drive. So I will be able to easily access my data. So I need not need to upload my images file again and again. So let's get started. So getting started with YoloV5, first what you have to do is you have to go to the YoloV5 GitHub repository. So how you will do it? So you have to just say YoloV5 Ultralytics GitHub repository. So you have to choose this first link. So after clicking on that link, you'll land up on this page. So this page has the whole lot of information about YoloV5, how it is performing. You can see your YoloV5S model. This is a model comparison between YoloV5X, 5L, 5M, and 5S, and with efficient data as well. So after coming to this GitHub repository, what you need to do is you need to scroll down a little bit, and you need to scroll down until you see a Google Collab file. So what you have to do is, when you'll come down in the environment section, you will see your Google Collab and Kaggle Notebook with free GPU. So what you have to do is you have to do nothing but you have to click on this open Collab. So it will open a Google Collab Notebook for you. And after that, what I'm going to do is I'm just going to change my account. So I'll close this previous notebook. So my notebook is loading. So yeah, it has loaded my notebook. After that, what I'm going to do is I'm going to mount my Google Drive. Okay, so you can also do by just dragging and dropping it here, your image files in zip format, and you can unzip it here only, and you can just use your data set directly. So my notebook is connected. So what I'll do is I'll mount my Google Drive. So what I'll do is I'll just do shift enter and I'll do it run anyway. So it's mounting my Google Drive. So my Google Drive is already mounted, and you can click here and I'll choose my account. And after that, I'll click on allow. So I'll copy my code and I'll come here and I'll paste it here and I'll do again shift enter. So by doing this, this will mount my Google Drive. So it has successfully mounted, and just refresh it. So you'll be able to see my drive here. So after that, what we have to do is we have to clone our GitHub repository, Ultralytics YoloV5 GitHub repository. So I'll just click on this run set and it will start cloning the YoloV5 repository. So it's cloning. So yeah, it has finished cloning. And if I reload this, you will see a YoloV5 GitHub repository. It has loaded here. So after that, after cloning a repository, if you scroll down a little bit, you will be able to see like how the YoloV5 is creating a bounding boxes, how it is detecting it. So this is the stock image which YoloV5 has already given us and has made prediction on this. So moving ahead, our main agenda for today is to train our model on custom dataset. So how to do it? So just scroll down and you will see a train. Okay, so inside this train section, what you have to do is you have to come here. This train YoloV5 on Coco 128 for 3 epochs. So now to train your data set on your custom data set, you have to make few changes. So what the changes would be, what you have to do, you have to go under data. You have to go under this data repository and you have to download this Coco 128.yaml. So click here, click on download. So I'll save this file. Okay. So I'll just save this file on my desktop. So I'll minimize this, minimize everything. So this is nothing but my Coco 128.yaml file. So I'll open this. So after opening this, we don't need this part. So we'll just delete this. After deleting that part, you can see your NC is equal to 80. This is nothing but our classes, which are already with YoloV5. So YoloV5 already gives you 80 classes, but we are training on a custom data set. So what we are going to do is we are going to change it according to our data set. So our data set have 2 classes, which are nothing but football and cricket ball. As you can see here, our data set has only football and cricket ball. So we have nothing but 2 classes. So I'll just change the number of classes here. And I'll also delete this and I'll give my class name cricket ball and football. So after doing this, what else you have to do is you can see your train and val. Okay, so I'll just increase the font size. So you can see your train and val. So make sure like your directory structure should be like this. So your folder name should have train and val. Okay, because YoloV5 will check for train and val. Okay, like if I come here I have uploaded my dataset already. So I'll show you how my directory structure is for YoloV5. So you can see here, I have images. Inside images, I have train and valid. Okay, so for that, I need to pass the dataset path here for train. I'll just replace this completely. And similarly for valid, okay, I'll replace the end part. Don't need this because we have more than 128 images. I'll just delete this and I'll save this. So after saving this file, what I'm going to do is I'm going to upload my YoloV5 custom underscore YAML under dataset data folder. Sorry. So what you have to do is you have to click on upload. You have to go on desktop where I have saved. So let's change the file name into custom underscore data so it would be easy for you to understand. So I'll rename this. What I'll do is I'll change the name. We'll pass custom underscore data. Sorry, it's custom underscore data, not dia. So we have renamed this file. What we are going to do is we are going to upload a file under this data. And I'll click on upload. I'll click on desktop, custom. Okay, so we have a custom underscore data underscore. I'll just rename it again so that I remove this underscore. I'm giving one extra underscore. So yeah, we have our custom. Delete this only and I'll rename it. Okay, so it's done. So if you can see here, we have our cricket ball and our football. Okay, number of classes, path to our data set, that's it. So after that, what I'm going to do is I'm going to replace this Scopo 128.yaml with our custom underscore data.yml. Okay, so we have our data set ready. So what are we going to do is we are going to start training our model. So let's begin. I'm just going to train my model for 3 epochs just for testing purpose. We'll see how we are making predictions and what is the precision. So this will be our first experiment. So let's begin with the training part. So as you can see here, the cell has started running and it has successfully opened dynamic library. It has downloaded the model, and after that it's loading. It's checking whether you have your data set or not. So it has found 300 images inside my training data, which is nice. So it's just caching the images for the train and for valid, so that it does not require to load your images again and again. So after that, you can see here we have started training. Okay, our training has started. So this is nothing but our first epoch. So it is training for first epoch. So let's wait for it. So it will take some time depending upon how big your data set is. So my data set for this tutorial consists of 300 images for training and 100 images for validation. So according to that, it's taking little time. So you can see here the mean average precision is 0.95%, which is pretty good. So we have trained for our first epoch, and it's training for our second epoch. So let's see how our model is going. So it has done training for second epoch as well. It's training for the last epoch. While training, so I have to tell you one thing. If your notebook stops, I mean training, like this cell stops training and you face a memory outage issue, so what you need to do is you just need to change the batch size. Just change it to 2 or 3. Just reduce the batch size. So you'll get rid of that memory issue. So it has done training. So you can see here, it has saved down weights in our model here, the best.pt, which is our model, which is trained on a custom dataset. So let's check how our model has made a prediction, which is you can check under runs, inside train, and inside experiment. This is nothing but this is our first experiment. So let's check the labels, whether it has properly given or not. So okay, it is predicted images correct. So we'll check for the labels. So you can see here it has predicted pretty much good. So you can't even see cricket ball here. So it has still predicted the cricket ball. Okay. So for this cricket ball as well, so it has predicted this for football as well, this for football as well, this for cricket ball. So this is very tiny cricket ball. I mean, you're barely able to see with your naked eye, but it has still predicted correctly. So if you can see here, football, cricket balls. See, he is holding the ball in his hand. Still, it is able to predict this is a cricket ball. So you understood how beautiful this YoloV5 algorithm is. So if we train for more number of epochs, we will be able to get good results. So let's train our model for 20 epochs. Let's see how it's performing with 20 epochs. So let's start with our training. So it's caching our images for training and for test. It is plotting labels, and it has started training. So you can see it started training, how many GPU memory, how much GPU memory it's using. It's locating, it's creating a bounding box here. It's locating the object. I mean, at what coordinate your object is. And you can see here it has trained for first epoch, and your mean average precision is 95%, which is very good. So people, I want to tell you one thing, like if you're not getting good results with respect to your object detection model, so what you need to do is, so first of all, do your annotations pretty well. Take time, take few days with peace in your mind. Just annotate your data very well, because if you don't annotate your data very well, you won't be able to get the desired results. Okay, because annotations are pretty important. And after that, if you consider one more point, like just have ample amount of data set, okay, inside your training as well, inside your testing testing part, because it will help your model to identify your objects within your images pretty well, and it would give you good results in the end. So it will take some time. It's still with the first epoch. So you can see here it's taking pretty much good time. It's some time. It's taking time to train because I'm using the standard Google Collab notebook. You can opt for Google Pro version, which is available with high RAM and high disk and with good GPU as well. And you will be able to train your model pretty much very fast. If you don't like waiting, you can go with Google Pro. So meanwhile, while our data set is training, so you can explore this notebook, like how it is. So you can give your predicted images as well, and you will be able to see your images, the predicted, your testing images. And the YoloV5 is pretty much good model when it comes to object detection. That's why I prefer only two, which is YoloV5 and Detectron 2. Both models have given me good results on my data set. So it's training for 15th epoch. So it's training for the last time. So let's see how it goes. So that's it. It has completed our object detection, and it has detected two classes here, which is cricket ball and another one is nothing but football for 20 epochs, and it took about 10 minutes of time to train our model. So the training which is done on a custom data set is saved in this directory under run experiment weights last.pt. This is our nothing but our model which is trained on a custom data set. So what are we going to do is we are going to check our experiments. This is about nothing experiment 2 for predicted labels. Okay, so this is predicted pretty much well. So you can see here you have football here over here as well. So it's still able to detect it. You can see here as well. football. It has detected cricket ball as well. So let's close this, and coming back to our Collab notebook, we have our object detection model ready on our custom data set, and which has been predicted with our images. It has successfully able to localize the images and to create bounding boxes across our images pretty well. So what are we going to do is we are going to check how my object detection model, which is trained on a custom data set, how it is performing on a video. Okay, so for that, what I'm going to do is I'm just going to go under this inference. I'm just going to comment this line, and I'm going to use my weights, which is trained recently. Okay, I'm going to select this model, and I'll replace this model with my model. And what I'm going to do is here, this is nothing but our confidence score. I'll increase my confidence score here. I'll give it 35. And what I'm going to do else is I am going to just upload a video, and I'm going to check how my model is performing on the video. Okay, so I'll upload a video on this. You can also drag and drop your dataset here, zip file, and you can extract it here. No need to upload your dataset into your drive, but make sure you give correct path in your custom underscore data .yaml file, because it's pretty much important, or else you will face an error. So what I'm going to do is I'll copy the path for this, and I'm going to just replace this with this. That's it. And I'm going to run this cell. So after that, what it's going to do is it's going to check frame by frame. Okay, it's going to detect the object. So for example, you can see here, see it's detecting football. It will again detect some football for this frame. Okay, so you can see here for this frame it will detect football for this frames also. So it's checking frame by frame where the object is. Okay, so you can see here how fast it's localizing the objects. It's taking like 0.24 seconds to localize and to create the bounding box across the image. So yes, our experiment is successful, and it's saved in YoloV5 under detect, runs under detect, under experiment. So this is our file. So what are we going to do is we are going to download it. So it's downloading my file. So this experiment completed in 37.399 seconds. So you can imagine how fast YoloV5 is. So let's wait for our MP4 file to get downloaded. So it's almost downloaded, and we are going to save our file. So we are going to give this YOLO red, and I'm going to save it on my desktop. Just save it. So I have saved it on my desktop. So you can see here, I'll just play this video. So you can see here how accurately it is detecting the football. Okay. See, ball here. So this is how it's predicting. See the confidence score as well. So if you train for more number of epochs, you will be able to see good results as well, because here it did some misclassification. Oh no, that's not the misclassification. That was a football over there only. So it is doing some misclassification over here. So that's it for the today's tutorial. Hope you like it. Make sure you like, share and subscribe to this video. This will motivate me to create more videos, and I'll bring some more exciting stuff which will help you in your day-to-day life, and it will make your life easy. And if you have any doubt or anything, you can reach out to me on my LinkedIn. You can message me on LinkedIn, and you can also post your doubts in the comment section below, and I'll be able to happily resolve your issue. So thank you very much. That's it for today's tutorial. This is Akhil Kasare signing off. Take care. Bye bye.